This morning we are going to work on something called a guide-orama, which is going to help you familiarize yourself with our textbook. So we're just starting out using our physics textbook. It's a very thick, dense book with lots of content in it. So I want to be sure that you understand how to approach something like this. So let's take a look at our purpose for the day. It says content and language at the top in our purpose. So we have them combined. Content is where you're really trying to unravel and get into the physics part of it, the science. And language is how do you look at text structure, at vocabulary, at figuring out the language of science and of physics in particular. So if we look at our purpose for the day, we're going to become familiar with the physics textbook structure. Okay, so that's kind of a language piece. The way physicists write is different than the way they write in history or the way they write in math. So we're going to look specifically at the textbook structure for physics, and we're going to also learn how to think about labs and texts in our book. So it's written in a little different way. We're going to get into the content of the physics. We're actually going to talk a little bit about free fall and start into kinematics a little bit today. But we're also going to look at how's our textbook structured, how's it set up. And then our social purpose for today. We are going to continue with talking to each other, with sharing ideas with a partner or a small group, and we'll also practice actively listening to our peers. Because speaking science, speaking physics is important, but also listening, being able to take in ideas and then use those ideas is just as important. So we're going to focus on both of those. Okay, so everybody should have their yellow guide-orama sheet. And if you could please open your book to page 2. And I'm going to model for you how you might approach doing this guide-orama and investigating your textbook simultaneously. So we all need to be on page 2. Now in your guide-orama, it's got the page number, which is the one we're starting on, and then there's a little tip for you. And the tip says, read the What You'll Learn section. So I'm going to focus on that, but I can see there's lots of other things on this page too. So listen in, I'm going to think about these first couple of pages to show you how I approach this book, and then I'm going to have you try it. Okay, so my tip said to take a look at the What You'll Learn section. And it says, you will use mathematical tools to measure and predict. Okay, well I know that in chemistry class and biology and many science classes we do lots of prediction. So I'm really not surprised, and measurement as well. You will apply accuracy and precision when measuring. Well, I remember in chemistry we studied accuracy and precision, and they're not the same thing, but I think that's something I'm going to have to check on again, because I really don't remember the difference, but I think there is a difference between them. You will display and evaluate data graphically. Well, that sounds like math. So these are the things I'm going to learn. So I guess it's okay if I'm not really quite sure about what they're all about right now at this point. So the title here is a physics toolkit. So I think I'm going to learn about what I need for physics, because that's what a toolkit is all about. Okay, and I see there's a why it's important. The measurement and mathematics tools presented here will help you to analyze data and make predictions. So there are lots of tips on this page here for me. There's red, larger print, what you'll learn. There's why it's important, also red, larger print. That's very important for me to see. And then there's this picture here I see of something in space, and it says, think about this. Physics research has led to many new technologies such as satellite-based telescopes and communications. What are some other examples of tools developed from physics research in the last 50 years? Wow, there's a question. I wonder if I'm really supposed to answer a question like that. Well, other things developed from physics research. Well, I know there's a lot of things that have come out of the space program, like some really strong materials that they use, ways to package food so that it lasts a long time. Okay, I'm going to just have to keep thinking about that question as I move along here. Now, in my notes section, read the what you'll learn section, I think I need to put down some things. So I know that from the reading, I'm going to learn about using math tools and about learning how to understand this book. So those are the things that I would write down in my notes section. Okay, now I'm going to move on to page 3. And my tip says, reach in your pockets, folks. With the partners at your table, complete the Launch Lab section. Okay, I wonder why I have to reach in my pockets. Let's see, I'm going to take a look at the Launch Lab. It says, do all objects fall at the same rate? The question, how does weight affect the rate at which an object falls? Okay, I remember in 8th grade studying weight and mass, and I think weight has something to do with gravity. And it relates to mass, but they're not the same thing. Okay, procedure. The writings of the Greek philosopher Aristotle included works on physical science theories. Okay, so that Greek philosopher Aristotle, some guy a long time ago that did some science things. These were a major influence in the late Middle Ages. Okay, I remember in history, late Middle Ages, long time ago, but I really don't remember what time period that was. But I don't know if it really matters. I'm going to keep reading. Aristotle reasoned that weight is a factor governing the speed of fall of a dropped object, and that the rate of fall must increase in proportion to the weight of the object. That is a big sentence. So I'm going to reread it, and I think I'm going to stop and just kind of try to look at half of it. Aristotle reasoned that weight is a factor governing the speed of a dropped object. Okay, that sounds like factor. I mean, that's a math word, and governing sounds like something I studied in history. Okay, weight is a factor governing the speed of fall of a dropped object. So maybe that just means weight affects how fast an object falls. And then the second part of the sentence, and that rate of fall must increase in proportion to the weight of the object. Okay, so rate of fall increases in proportion to the weight of the object. Okay, so maybe that means that the bigger something is, the more it weighs, the faster it falls. Oh, now I get to actually do something here. It says, tape 4 pennies together in a stack. Place the stack of pennies in your hand and place a single penny beside them. Observe, that's in red print, which is heaviest and pushes down on your hand the most. And then 4 says, observe, drop the 2 at the same time and observe their motions. Okay, I'm going to do that. So I have 4 pennies here, and I'm going to tape them together. And I have a single penny. Okay. And you will be able to try to do this too, but for right now, I just want to show you, here's how you approach these kinds of things. So the first part says to put both in my hand and see which is heavier. It's actually kind of hard to tell. Maybe if I put them next to each other like this. I'm going to try modifying this a little. This feels slightly heavier. This is the one with the 4 pennies stacked together. Yeah, it makes sense. I mean, it's 4 times the weight. 4 times the mass there. So now I'm supposed to put them both in my hand, and it said that Aristotle said that the heavier one should increase in speed. So I would predict, because I know it says I'm supposed to predict, I would predict that the 4 will fall faster. Okay, I'm going to try it. Will you help me count to 3? Okay, 1, 2, come on, 3. Wow, that looked pretty close. I don't really think that this one hit any faster. I have to try that one more time. Okay, here we go. 1, 2, I like that, 3. Wow, my 4 fell apart, but they hit at the same time. So I wonder, could it be possible that even though I read this in the textbook about Aristotle, that maybe Aristotle was wrong? I don't know. I think I definitely am going to have to read a little bit more here because my data did not show that the 4 fell faster. So, analysis. According to Aristotle, what should be the rate of fall of the single penny compared to the stack? What did you observe? Well, if Aristotle's right, the 4 pennies should have fallen faster. But I did not observe that. So, critical thinking. Explain which of the following properties might affect the rate of fall of an object. And then it gives me some options. Size, mass, weight, color, shape. So these give me some things to think about. Okay, so sometimes in science, what you read in the textbook is there to ask you some questions, to help you think about the content. So even though I read about Aristotle's ideas were before some other researchers who were able to investigate this more, such as Galileo. And when Galileo studied falling objects, what he did was roll objects down inclined planes, and he increased the angle at which he rolled the objects like a marble. And he found that as he increased the angle, all objects, no matter what size, would fall at the same rate. And so he used this study to predict that there is a rate at which objects increase their fall in speed. And he called that acceleration due to gravity. So we're going to be studying that later. You're going to do lots of investigations in which you try to figure out how things fall, what affects their fall. Maybe it's size, maybe it's shape, maybe it is mass or weight. So we're going to investigate from what Aristotle said, or maybe are some other ideas like the ideas of Galileo correct. So we'll continue this. I would like you to continue trying to read the textbook just as I have, and practice a little bit with thinking about what you're reading and then going back to your note guide to fill it in.